This set of data representing the heights of club members is presented in what is called a grouped frequency table. And as you can see, there are frequencies, and the height is presented in groups, in intervals. So for example, in this interval, there are 30 people who have a height from 150 to 160 exclusive. Obviously, this class can be represented by the inequality 150 is less than or equal to h, which is less than 160 centimeters. Now, this kind of data can be processed and be presented in what we call a cumulative frequency diagram. And that's what we'll be considering now. Cumulative frequency is a way to present data, and also it's a way to extract the median of this of the height. Now let's consider this particular table and let's convert it to a cumulative frequency table. First of all, we still have the height in centimeters, and instead of frequency, we have cumulative frequency. We look at the intervals. The shortest person in this club is 140 centimeters, or at least seems to be, and the tallest is 190. Keep in mind that we don't know how those 20 people are distributed in their interval. They could all be at 140, they could all be 145, they could be distributed evenly or unevenly, we don't know. And in this case, we have lost some detail but gained clarity because we ended up with grouped frequency rather than individual heights. So we know that there is no one whose height is less than 140. So our heading here is less than 140 and there is no one, so the frequency is 0. But if we consider the heights of people, the number of people whose height is less than 150, well, obviously there are 20 people, which are the people in this interval. However, considering the people whose height is less than 160, we have those and those. So that's 50. So we add 20 plus 30, giving us the 50. And for people who are shorter than 170, we add the 40 to the 50, giving us a 90. And finally, we do the same to get those who are shorter than 180. We add the 35. And when we add the 15 to the 125, we get the 140. And that tells us that there are 140 people in that club. So the sum of the frequencies is the value that appears in the last entry in this column. So we have seen how to move from a frequency table to a cumulative frequency table by simply adding the frequencies or accumulating the frequencies. To do it the other way around, if this is the cumulative frequency table, how do we go to the frequency table? In this case, it's obvious that we begin at 140 to 150. So you may write it in this form, or you may decide to write it as 140 is less than or equal to the height, which is less than 150. This conveys the same information, but it's a lot easier to write it in this form. Keep in mind that because this is equal to, then this is 180 to 190. Now, This tells us that we begin at 140. This tells us that between 150 and 140, we have 20. Between everybody that is less than 160, there are 50 of them, but 20 have already been recorded here. So 50 minus 20 gives us the 30. 90 is the number of people that are below 170. We have already recorded 50 of them, and there are 20 and 30 here. So 90 minus 50 is 40. Similarly, 125 minus 95 is 35. And 140 minus 125 is the 50. So we can move from a cumulative frequency table to a frequency table by subtraction. Now, let's go back to our cumulative frequency. This is our set of data. It seems quite logical to try to plot this to get a graph. So we ignore the fact that this is less than 140, and we simply draw a point at 140, 0. So we have this point. 150 at 20, we have a point here. 160 and 50, a point here. 170 and 90, 180, 125, and a point underneath this table. So those are the points, but we really don't know how to connect them. Because we don't know how the 20 people here are distributed in the interval. If they are all at the end of the interval, then they'll probably be like that. If they are at the beginning, the curve will be like that. But since we don't know that, since we don't know how the people are distributed in the interval, what we do is just we connect those points with a smooth curve. And we get those points, and then we connect them with the curve, and this is what is called a cumulative frequency curve. Note that the end is 140, which is the total number, and at the end here, the 140 represents the shortest person, and the 190 represents the tallest person. Now this curve can be used to extract a lot of information that cannot be obtained directly from the curve, from the table. So let's say that we want to ask the question, how many students are shorter than 155 centimeters? What we can do is we go to 155 and then we draw a perpendicular line to meet the curve. And then from that point we draw a horizontal line until we intersect the cumulative frequency axis, which is the vertical axis. And we read off the value on the x-axis, on the vertical axis, and that's 34. This tells me that there are 34 people that are shorter than 155. Keep in mind, this end of the cumulative frequency axis represents the shorter people, and this represents the taller people, because that's how the table was constructed. But to answer this question, the number of people shorter than 155 is 34. We could not have got that answer from the table directly, but from the curve we can easily manipulate the curve to get the answer. Let's take another example. How many students are taller than 175? Well, we do the same thing. we go to 175, we draw a perpendicular line until we meet the curve, and then we read off the value from the cumulative frequency axis. And this value is 109. However, the people taller than 175 are the people from 175 to 190. This corresponds to this number of people, from the person number 109 to the number of person whose number is 140. So this interval represents 140 minus 109, and that's 31 persons are taller than 175. Let's try something else. How many students are between 172 and 185 centimeters of height? Well, in this case, we do the same process, but we draw two lines from 172, which is approximately here, and from 185, and then we draw our horizontal lines. And we read off the values from the axes. This looks like probably 98, and this looks like 134, for example. So the people who are between 172 and 185 centimeters of height are the people whose numbers are between 98 and 134. So they amount to 134 minus 98, and that's 36 persons. If someone says that 10% of the students are taller than X, so we are looking at the top 10%, because the key is they are taller than X centimeters. And 10% of 140 is 14. So we would be looking at 126, because those 14 people from 126 to 140 are the tallest 10%. What is the height of this person? Because this is the person above which there are 10%. The process is the same, but it's done in a reverse way. We identified this value on the cumulative frequency axis representing the top 10%, and then we go across and down, giving us a height of something like 181, maybe a little less, but then this value is 181. The heights go from 181 to 190. Those are the tallest people, but this tells me that there are 10% of the club members are taller than 181. Again, 20% are shorter than Y, so we're talking about the shortest 20% of the students. And if we have 140 students, then 140 times 20%, that's 28. We are looking at the shortest 28 students. So we locate 28 on the cumulative frequency axis. and then we do the same process again. And this looks like 153 perhaps. So 20% of the students are shorter than a certain height, and that height is 153. So from 140 to 153, there are 20% of the students, and those are their heights.